Yeah, so my presentation today is about data processing with options. So since you know more and more we are going into auto pipeline automation and things like this. And with newer generations and new users especially, we hear more and more that they abandon a few things. They don't think anymore about what is been done in the background, right? So it is always good to remind also, not only you, but also later we will upload these slides up, right, in our forum that, for example, your students can have a look at these things. So auto pipeline, this is usually how it goes, right? If we collect the data, what is happening concurrent in the background is always indexation, data reduction, and if we have enough completeness, of course, from what is this experiment or full experiment, even AutoCAM will solve it. The atom assignment can be wrong. And this is one thing that you should always have a look at some point, right? Does it make sense chemically or not? But usually if your samples, your crystals are well behaving, I'm not saying well diffracting because this is a different story, this pipeline works pretty nice. But if it doesn't, there are some things that you have to consider. So we like to do some polls, and this is what we can also do right now. So you see here in Lattice Wizard this unit cell with quite good indexation. So let's just do a questionnaire here with raising your hand. So how many of you think this is a single crystal where we can get the crystal structure from?
Yeah.
That's the difference between a normal user and a guru, right? This is what I wanted to hear, exactly. So if you are not familiar with anything and you see this one with the unit cell, it makes also sense, right? Monoclinic C-centered.
Monoclinic C with a long axis.
Yeah, but not too long, right?
It can be also triclinic, twinned into monoclinic.
Exactly. So what we have seen, or one of the students has seen when he or she did, or them, or they did the experiment, they couldn't solve the structure with this.
Yes, of course, as usual, automated to Ubuntu.
Exactly. So now, if we are looking in the Ewald Explorer, very good. And you look here at the histogram, it looks ugly, right? It doesn't really make sense. So what we did then was to do auto unit cell finding just very quickly ourselves, and suddenly it makes a little bit more sense. But still, this is now looking into C star or C direction along C. It looks strange because from time to time, you can see here a reflection, then there's something missing, and then there again. So if you now manually use, for example, the here this option lattice it, or the selection, you can now deconvolute those things, and suddenly we get a way smaller unit cell, and it also looks reasonable. I think this one is orthorhombic T or something like this. And then if you also, monoclinic, yeah, sorry, it's monoclinic, and then if you also check for example, twin, suddenly it makes all sense. So for good practice, always have a look into Ewald Explorer, and not only trust on the indexation that you see during the screening or during the pre-experiment. Always go back, one step back to Lattice Wizard, or and then use the Ewald Explorer. So always also have a look at the big picture, not only the statistics that you see on the right side, but it might also be worth to check the frames that you are collecting, right? And this will also might have an influence on your strategy calculation. Another thing that we often see, especially if you do variable temperature experiment, is that it can happen if you go, for example, from low temperature to room temperature and do the same measurement there, and you haven't glued your crystal, for example, that it might be, and depending on the orientation, because we have gravity, right? It can be that the crystal is moving or shifting or whatsoever. So in CrysAlisᴾဍ we call it sudden orientation change. So it's a sudden sudden movement of the sample. It can happen several times, and it can be gradually. So what CrysAlisᴾřej can do basically is to correct this one to some certain extent. How do you usually can see these things happen? So if you do a what is this pre-experiment or screening, usually you get an idea of is it a perfect single crystal or not. And then if you do the full measurement data collection, and suddenly the R values, the internal R values or whatever are increasing, you might, or maybe the indexation level is low at the end if you do the whole peak hunting. It might be that you see something strange happening suddenly. So in this case, if we, for example, take out the last 3 runs, it looks nice. But then, if you take the other 3 runs and include them, it looks like this here. So what we can do is, if you go to unit cell finding and use this small arrow here, which is right now below this box, we have these options of checking for sample jumping, right? There are different options, and then here you get the summary. So if you don't check for the crystal jumping, the indexation level is quite low, so 50%, although it was before around 98% or something like this. If you now check for these things, it looks okay. So nothing, you don't have to recollect your data, basically. We can correct this within our software. How to do this? If we now go to data reduction with options, just a reminder there are 6 different steps, right? And in the step 3, especially here in this box where we would go for the prediction of the reflection positions, there's one box which says follow sudden discontinued changes of sample orientation. We can only correct it if it's within 10% or 10 degrees of a change of the orientation. If it's more than that, I'm sorry, you have to kick out a few runs or frames, or even recollect this data set.
Or process separately and merge.
Yeah. Or process them, exactly. Yeah.
Is this always checked and then, or you?
No.
No,
it's unchecked?
Normally it is unchecked. Yeah, because it is also quite, it takes some time to compute everything. Okay. So usually you would not check this one. What is checked is usually these 2 above this one, but not the continuous change.
I would say the concurrent process, they have a test and then they enable it when they discover it. So I got tricked once because I was full, like Kai said, that you have to manually be on. No, they sometimes find it. So
yeah. So let's have a look at one of the examples. If you correct it and without correcting it, as you can see, without correcting it, the Rn is really high, which is looking more like electron diffraction data sets, but it was an X-ray, right? So we wouldn't expect something like this here, and if we correct it, suddenly it looks much more reasonable. The completeness is also quite okay-ish. It could be better, but yeah, we will take this one. Another thing that you can do in the options is to have a look at the mask size. So usually what we have here is that there may be cases where you want to manipulate the mask size. What we always have is a fixed size, but you can increase and decrease it. Yeah. What is happening often is that you have a slightly split crystal, where then in higher angles or somewhere else, you can see that the reflections get separated nicely. We have a model for this one. So in this case, it could be processed as a twin, for example, and there you can here often make the mask smaller to reduce the overlap between those ones, right? If the separation is not enough, what you can do then is to make a very big profile mask and work as a single crystal data set, right? When shouldn't you use this, or when shouldn't you change anything there? If you have already good quality single crystal data sets, it doesn't really make sense to change there anything, because it can even be that you make it everything much worse and you get worse data sets. Again, let's have a look in CrysAlisᴾřej where you can do these. We are again at step 3, but now if you go to edit special parameters, there's one box here, right? If you check this one and click on edit, there's another box or window opening up, and there you can change either the integration mask with one value, or if you want to do it with 3 values, you can also edit these ones. Very easy.
One should say not integration mask, but profile learning.
Profile prediction learning, yeah.
Because the integration is actually done in this area.
Yeah.
So this is only influencing the profile learning. And if in the profile learning, of course, you have overlapping reflections, or they can then misinterpret the profiles. That's
right.
The main.
Yeah. Yeah, right. Thanks. Another thing, the next thing would be the sudden profile size changes. And what it does basically is, if you are looking here now at your X-rays, you have your sample here. Most of the time, if you get some peaks here in the middle, they are quite sharp, right, and small. And then, depending on if you go a bit further out, it gets a little. They always look like this, right? This is what we can easily correct if you have if you have put a tick mark here. Another thing that we can also do is for high angle prediction uncertainties. Again, if you put here a tick mark, it will be corrected automatically. When should you use it? Especially for weakly diffracting high mosaic crystals, where you can really not easily predict the accurate position of those peaks at high angles, and then it will be most of the time very reliably improve your data sets. Smart background, when to use it? It's usually used when you have a very high variation in your background. So if you have a fluorescent sample, what it does usually, our program will nicely correct this one. If you have already a background which is low and stable, you would usually not use the smart background. With the newer detectors, smart background is always the option of choice. Right, here we have a table, for example, looking at one of this compound here. If we go for the average background, we got only rather good data sets to a diffraction limit of 1.4. If we do the smart background here, suddenly it is much better. Of course, not yet for publication, but still good enough to get the connectivity and some information out of these. Where to do this one? It's in step 4, background evaluation of our profit window, and then it's this one, the smart background, that we would choose instead of the average background. Profit loop, we have heard about this one already this morning, so I do not need to talk too much about this part. Again, if you're not subscribed to our newsletter yet, which Joe is the editor of, please either scan this QR code or go to this website, because we provide every month now some tips and tricks on hardware or software side. Most of the time software side, and as you have seen this morning, there were a few things that you could learn from one of us. This is again the workflow of the profit loop, very easily shown. So basically you have to open in the offline red version of CrysAlisᴾřej a data set. You would then type in x's profit loop here inside of the command shell. You would go through the general settings in profit. If you click on OK, you will get this window. You can then select if you want to do a single run of one of these options here, or it's called here multi-run. So it will basically do both. It will do a single run yes and a single run no for one of these ones, and then you can get a lot of combinations, which will be tried automatically via a script by our nice software. And then you can have a look and inspect those things in our refinalization tool. One example here is with 16 runs, so basically 16 different combinations. It took at the end 29 minutes. This was done with I don't have the fastest laptop, and then you can compare all those different combinations, and for example, take the best one out. You can also clearly see which one is not favored for this experiment, right? This is a nice thing. You could do this for every sample, but to be honest, it makes sense to make on challenging samples these steps more. Yeah.
Am I right in thinking you can't vary the smart background width as part of the loop?
No.
No.
It doesn't make sense.
Why does that not make sense?
Because it's if you make it as a combination of it, it will change too much things. And like, for example, mask overrides and so on. So it's just a favorable combination.
The smart background is one of the more computationally heavy options. So if you did it 3 times instead of once, the whole processing time will start to get.
For example, your high pressure data benefits from having a particular one over another sometimes.
Generally speaking, I'm not a big fan. What we thought when we developed that was that at the one extreme point you go from 1 frame and get the background, and normally you take 50 frames to take the background. So this one where you do now 3 frames to take the background is somewhat like a compromise. It was never shown that this is actually good.
When you say good, do you mean better or?
Better than the single approach. You know,
we've had quite a bit of high pressure data where 5 on these now half degree frames is, I say better, right?
I always used to use 3 or 5. I did try to do a systematic study at one point, and 5 was slightly better, but you're heading more towards the situation you have in the average background approach if you do that.
So
it's only for high pressure that seems to be the case.
Maybe.
So then you've got much more.
It is there as an option, but it's not be in this profit loop.
Yeah.
This profit loop was developed when we studied sponge crystals, because sponge crystals are extremely tricky to see what kind of parameters are finding this different structure very precisely. Yes. So this is when all these tools were developed. Smart background was not one of the options which was
used. Did you fine slice your high pressure data set? What was the...
How fine do you mean?
Like, was it...
I think generally we collect with 0.5 or 0.25 degrees.
Right. Shall I continue? So if you now run the profit dialog, right, what you should not forget is that you should also do data visualization. We had a few examples already where they didn't do any post corrections there, and you will see in a second that it makes sense to do these. And it should be, this is not part of the auto pipeline, but it should be in your manual auto workflow, basically, that you should do to correct your things. And I will not talk too much about this part because it was part of the Rigaku School for Practical Crystallography, which also Joe will talk about later on, not about the data finalization, it's actually, but more about the success or the history of the school. We have uploaded all our lectures there, so if you have new users, please ask them to have a look at these ones. It starts from crystallization to how to mount a crystal, doing a proper calculation, strategy calculation, to finalization, data reduction, and also part is from Horst, for example, talking about OLX2, how to solve it and refine it, and also getting a CIF file afterwards for publication, ready for publication. But let's have a look at some examples why it makes sense to do those post corrections. So if we don't do any corrections, we have two different examples. One is an organic small molecule. If you don't do any examples, the R int value is quite high. I over sigma 23, R1 3.7. If we just do the empirical correction, it drops quite a lot. And in this case, the numerical absorption correction will not change anything. If we are looking at one example by Mr. Dušek, we could see that here it is even more drastic. So if we only do empirical, we can drop it already quite nicely. If we do numerical, that's also not too bad. But if we apply both of those ones, we get the best result. Right? Good. So for summary, auto pipeline built in CrysAlisᴾEØS is quite powerful, and a lot of people appreciate it. But still, we should make sure that it is not misused by a lot of people, new users especially. So we should train them properly to show them how the proper workflow is and what is behind all those workflows. Right? It works nice for non-challenging samples, but if they are challenging, it's more. Yeah. Manual data processing with options is unavoidable, I guess. Lattice Wizard, Evaluate Explorer is also a nice tool to check if those statistics that you get are correct or not. And then please be careful with AutoChem. It's quite reliable to give you atom connectivity, but it might be that some atom is not properly assigned. And if you want to, don't use this one, the AutoChem structure, to publish directly your data. This has happened several times. Also, from what is this, they try to publish something. This is not enough, right? Yeah, that's it. Thank you.